Section 4.3 deals with the law of cosines, which is another way to solve triangles, but this is for the side angle side situation or the side 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 situation. And in the book they actually give 3 different rules, but in class I will give you a shortcut, but and I'm using somewhat of the way the law of cosines is stated on page 270 rather than 269. But basically, if you use the fingers that I've shown you in class, you can learn all 3 in just one. And so during class you will see quite the shorter version. So we look at number 1. Now, unlike the law of sines, when sometimes we change the values around, we don't do that with the law of cosines. And the only time we do it on the law of sines is when we have the side angle situation. So suppose we have what number 1 is shown. That's side B and 10, A and C. And we need to solve the triangle, which means find the missing pieces. Here we have side angle side. We know the 2 sides and an included angle. So we need to use the law of cosines. Now the law of cosines basically will be the side opposite the angle we know. Or if we don't know the angle, then we just choose a side, and as long as we make sure the angle, whenever it's mentioned, comes up later. But the side opposite the angle squared is equal to the 2 sides that we know squared added together, very similar to the Pythagorean theorem, minus 2 times the 2 sides we know times the cosine of the angle we know. Now, if we knew all 3 sides, then we would put that value here, and we would put the cosine of B. And then we would solve for B. But in this case, we're solving for little b. So b squared will equal 4 plus 100 minus 40 times the cosine of 35 degrees. Or approximately, this equals, and it's just a matter of plugging it into your calculator, and we get this is equal to approximately 71.23, but we're going to keep that value in our calculator because we're not quite done. Instead, since that's what b squared is, we're just going to take the square root of that value we just calculated, and then we get to do our rounding. Same rules apply. The number of decimal places here is 0, so we're going to go one further than that, or to 8.4. Now, once we find the side or one of the angles, depending on what we know here, then we immediately go to the law of sines. So the law of sines will now look like this. The sine of 35 degrees over 8.4 will equal the sine of A over 2. And just pick one of them, because it doesn't really matter, because once we find this angle, then we can calculate this angle here very easily. So finding A, we're going to do the cross products. So we get 8.4 sine of A excuse me, equals 2 sine of 35 degrees. Sine of A would then equal, dividing both sides by 8.4, 2 sine of 35 degrees over 8.4. And so, to find what A would equal, we just take the arc sine of both sides. So the arc sine of 2 sine of 35 degrees over 8.4, and this is an angle, so we're going to round to the nearest whole number. So I need the arc sine of 2 times sine of 35 divided by 8.4 is equal to, and rounding to the nearest degree, is 8 degrees. So, finishing up, and realize this 8 degrees should be here. It's just a little bit messed up. So all we then need to do is to calculate C. So C would be 180 minus the two angles added together, 35 plus 8, or 180 minus 43, which equals 137 degrees. And so we will have, and I'll put the 8 degrees appropriately in there. And there are the triangle solved. Example number 2 is same thing, it just gives us the answers or the problem without a triangle. So I like my A on the left angle, my B to the right, and C up above. So little a is 70, little b is 12, and angle C is 105 degrees. We have side angle side, so the important angle becomes angle C. So using the law of sines, the side that's missing, squared, is equal to the two sides we know squared minus 2 times the two sides we know times the cosine of that included angle, which is 105 degrees. Or 144 plus 4900 minus 1680 cosine of 105 degrees. And so C squared will equal approximately 5,478.82. But we want to know what C is, so we just take the square root of that, and we get, rounding to one decimal place, 74.0. So since we'll just do it at 74, because it's not really going to make a big difference here. So then we do the law of sines. Well, I certainly need the sine of 105 degrees over 74. And then it doesn't really matter which one I choose, so I like A, so I'm going to take the sine of A over 70. And then I need to solve for A. So doing cross products, I'll get 74 sine of A equals 70 sine of 105 degrees. The sine of A will equal 70 sine of 105 degrees divided by the 74 that we divided from both sides. And to find A, we just need the arc sine of 70 sine of 105 degrees over 74. And since this is an angle, we can do approximately, or to the nearest whole number. So we take arc sine of 70 times the sine of 105 divided by 74 is 66 degrees. And then finally B is easily calculated as 180 minus the 105 degrees plus 66 degrees, or 180 minus 171, which equals 9 degrees. And there is the triangle completely solved. Example 3 is very similar to the two previous ones. So I'm going to start out with drawing the triangle. But A, B, and C, it's just my habit. Little b is 4, little c is 5, and angle A is 85 degrees. This is side angle side, so we must use the law of sines. So that would be A squared is equal to 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of 85 degrees. And so a squared is equal to 37.51. And so to calculate what little a would equal, we take the square root of that, and get 6.1. So now we can use the law of sines. We especially need this. The sine of 85 degrees over 6.1 is going to equal, well, it doesn't matter B or C. I like B because it comes first. The sine of B over 4. So doing cross products, we will get 6.1 sine of B is equal to 4 times the sine of 85 degrees. Divide both sides by 6.1. Then take the arc sine of both sides. Since this is an angle, we get to round to the nearest whole degree because we're not told otherwise. So we take the arc sine of 4 sine of 85 divided by 6.1, and we get 41 degrees. And so angle C is easily calculated as 180 minus the 85 plus 41, or 180 minus 126, which will equal 54, or 54 degrees. And finally, angle 3 is finally determined, or triangle 3 is finally solved.